Bismillah ar-Rahman ar-Rahim. Previously, we had talked about the four special segments in a triangle, specifically the perpendicular bisectors, the angle bisectors, the medians, and the altitudes. And we had observed that all of them were concurrent, in that the perpendicular bisectors all met or intersected at one single point, and the same with the angle bisectors, the medians, and the altitudes. Today, I wanted to take into consideration some special cases of these scenarios and set the stage for our future discussions of each of these individually. So the first thing I wanted to bring to your attention is that three of these start at a vertex, and these are the median and the angle bisector and the altitude. So the median starts from the vertex and goes to the opposite side like this, and of course therefore bisecting the segment there. Okay, that's the median. And the angle bisector, of course, also starts at the vertex and divides the angle over here into two parts. And finally, the altitude starts at the vertex and lands perpendicularly to the other side. So three of these segments start by definition at the vertex. Okay, so from the vertex to the midpoint, from the vertex as bisecting the angle, and from the vertex to the opposite side at a perpendicular angle, like that. Okay, so the median and the angle bisector and the altitude, they start at the vertex. And one of these, and that's specifically the perpendicular bisector, does not necessarily, or does not start at the vertex, but rather it starts at the midpoint, and it is perpendicular to the segment AC in this case, like this. Okay, so the perpendicular bisector of these, okay, is the only one that does not have to necessarily start at the vertex. Okay, so let me try to highlight that over here, make it a little bit more obvious like this. So here's the perpendicular bisector. Okay, so that's one critical difference, is that three of them by definition have to start at the vertex, and the perpendicular bisector is the exception that does not necessarily have to start at the vertex. Now what do you mean by not necessarily, business, right? Okay, watch. Now consider this, for example, this is an equilateral triangle. In an equilateral triangle, which is a very special case, the altitude, the median, and the perpendicular bisector and the angle bisector all be the same. So if I were to, for example, draw an altitude from there to there, then these two triangles, the triangles created, would be congruent, and it can be easily shown that it is the perpendicular bisector. And if you draw all the three altitudes, you'll see that they are the same as the medians, the angle bisectors, and the perpendicular bisectors, because a median plus an altitude, if they're same, will be the perpendicular bisector. So in the special case scenario of an equilateral triangle, these four segments will all be the same segments. The perpendicular bisectors, angle bisectors, the medians, and the altitudes will be the same for an equilateral triangle. So I just wanted to explore these relationships and to suggest by definition, the angle bisector, the median, the angle bisector, and the altitude all stem from the vertex, and the perpendicular bisector does not have to be, but they can overlap from time, given certain circumstances, as in the case of the equilateral triangle. Inshallah, next time we shall examine each of these fascinating segments individually. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.